Hey guys, just want to quickly upload a video to accompany the one that I just posted on how I'm thinking about taking the numbers that we're going to measure in the lab and translating them into something that we can compare to published numbers. So, as you know, the basic idea here is that we're creating a circuit and we're going to have a current go into that circuit, and we're going to look at the resistance that is created by going through a cylinder that has our material in it. And so the more ions that are dissolved in the water, the easier it'll be to for that current to pass through there. And so the two numbers here that matter are the resistance, which is this capital R here, that is the actual thing you're measuring, and then the resistivity, which is an intrinsic property of the material, and that's something that we can compare to other values. So down here I have resistivity for water, pure water, drinking water, and seawater, and you can see that the resistivity goes down as you add ions. And the units here are ohm meters. Okay, and so what we can do is we can get the area and the length of the cylinder that we are using in the in our particular instrument that I made over the weekend. And so what you get is that if you plug in the 7 mega ohms, which is what more or less what I was measuring using that mixture that I made, you can translate that resistance into a resistivity, and you get that it's 88 times 10 to the third ohm meters. And so, assuming I was using DI water, so we started up here, and so the resistivity went down in about the 5 minutes between the time I mixed up this mixture and put it into the cylinder. It was taking up some ions, right? Because the pseudoelastinite was dissolving. I would expect that it would dissolve more the longer I waited, although I didn't do a test to look at time. So we'll want to be mindful of time when we do the measurements, right? You don't want to let it sit for 45 minutes, for example. But I do think that this approach is going to begin to give us some measurements for what the resistivity of the water is in our system, which is going to both capture the water to binder ratio and the particle size. So it'll be good to start collecting these data and then comparing these to the strength measurements that we're collecting. Okay, great, thanks.